Hey guys, my name is Shashank, and on this channel, I show you the real work and day-to-day activities of data analysts. Today, we're going to be working on a data cleaning exercise, where basically I will show you data in its pre-clean format, its post-clean format. You can pause the video and try and do it yourself, or I will walk you through the entire process I used. Some questions I often get whenever I do these data cleaning exercises are, why do you use Python instead of using something like Power Query or something? For those that don't know, it's basically something built into Excel that's specifically built for this kind of stuff. And the main reason is because data cleaning is usually just the first part of an entire analytics process I might go through with either my client or my company. And because of that, it usually makes more sense to do all the steps in Python. That way I'm not switching between languages and having to do that context switching, which might be a little bit difficult for me to actually process. So for example, like I might want to run some statistics or run some machine learning algorithms on the data after I'm done cleaning it, or even like load it into a SQL database. Usually we load it into SQL databases. And it is generally easier to have everything inside one Jupyter notebook. For anyone not aware, Jupyter notebook is just a like a markdown plus Python format of holding your data inside Python. So that is the main reason I decided to use Python for all these processes, even though Power Query might be easier. It's just what I use for about everything. All right, without further ado, if you're interested in following along, the dataset is linked in the description below. So here's the data, and this is the format that it was currently in. Basically, each of these sections over here, where it says like first name down to total, is like one data set. And I need to combine all of these into like one massive data set. So you'll see each of these is like a section of data. You can kind of think of it as like a separate sheet in an Excel sheet, but this is all in one CSV. And the final format I want the data in is something like this, where, as you can see, I have the first name, the last name, the date, and then these 10-ish columns right over here. Row type, iter number, power 1, speed 2, electricity, effort, weight, torque. So this is the final format I want the data in. So let's go ahead and get started. See if you can do this yourself, but if you're just here to sit and chill, actually it was really funny with my SurveyMonkey video. Some people just like watch it on the weekend for fun. Feel free to do that as well. All right, so let's get started. So I opened up my Jupyter Notebook. For anyone wondering how I got Jupyter Notebooks to work in Visual Studio Code or how I got this set up to work, go ahead and check out my video linked over here, which is basically my data analyst and data science setup basically on my computer. It's how I set up my software on my computer whenever I start something new. So, all right, here we are. I am recording. Got to make sure. I did this entire video once and then found out I didn't record anything. This is my second take actually. All right, so first of all, we're going to import pandas as PD. The great thing about Python is that it is a programming language with many different libraries that allow it to do umpteenth number of tasks. So pandas stands for panel data and is basically the main library used to interact with tabular data in Python. So we're going to import pandas as PD, and let's go ahead and import this data. So looking at my directory, it looks like the data is called datacleaningchallenge.csv. So I'm going to create a variable. We'll call it data import equals pd.read_csv. PD refers to pandas over here. Import pandas as PD. So read CSV, we're accessing the read CSV method. We're going to call it data_cleaningchallenge.csv. And then I'm just going to put data import over here so I can take a look at the data. All right, so I see that we have a bunch of unnamed columns over here. So what I'm going to actually do is I'm going to go ahead and take this row over here, which is good. This is going to be the names of at least some of our columns, and then we have like 3 other columns over here, and I'm going to make that our first row. And I'll show you why I'm doing that in a minute. So let's go over here, and this is one of those instances where I'll probably just edit the base file. But generally speaking, if I know I need to do this task repeatedly, I wouldn't do it this way. So I just copied that, enter, and then pasted that. So save, and then let's go ahead and read it in again. And as you can see, we've changed our first row, our headers, to say these column names over here. So the basic method I think I'm going to follow is I need to find a way to group these rows together. And then what I'll do is I need to separate this from this and then join them together like this. So what we kind of want to do is we kind of want to like take this, Control X, put it over here. And we need to find a way to match each of, like all of these together. So what I think I'm going to do is I'm going to like create a column called iteration, and it'll have a number associated with each group of values, headers and values, kind of like this. So you'll see all ones, all twos, all threes, and so on and so forth. So let's go ahead and try that. So let's see, how would we do this? Oh, well, first it looks like we have 2 extra columns over here, so let's go ahead and get rid of those. The easiest way would probably be just to go to the base data over here. And you see, and this is a CSV. This is a CSV in text format. It stands for comma-separated values. As you can see, every record is separated with a comma, and then the new row is denoted by a line break or an enter. I could probably just get rid of those 2. But it looks like every, as you can see, every couple of rows has these 2 over here. So I need to drop it, instead of getting rid of all these manually, I'll just drop it inside Python. So let's create a new variable. We'll call it drop extra, and we'll say it equals data import. So we're referring to that data import dot drop. So just drop, and then I need to specify what I'm dropping. So I specify columns, and I want to drop unnamed 9 and unnamed 10. So copy that, unnamed 9, and then unnamed 10. And then I should be able to preview the data frame by just typing in drop extra over there. And as you can see, we have now dropped these 2 columns over here. Cool. Now the next thing I'm going to do is I'm going to create a for loop. So I'm going to create a list. Because what happens is I need that new row with all the iterations inside it, right? So I'm going to create a list, and in that list I'm going to have basically every time it sees first name, it'll go to the next value and then paste that value until it encounters first name again. That way I can group all of my data. So let's go ahead and try that. So I need an empty list. So we'll call this column values equals empty list. And then we'll go ahead and do counter equals 0. And then let's do a for loop. So for I in, and then I'm going to iterate through this row type column over here. So for I in, drop extra, row type, if first name in I, and the reason I'm doing this instead of like setting it to first I equals first name person is because this person might change. It might say John, like first name John at some point in time. So I'm just checking if first name is in it. So if first name in I, counter plus equals 1. So basically take, writing something like this in Python is the same as writing that. It's just much shorter. I forgot what the exact term for this thing was, but it makes that a lot shorter. And then we want to take column values and then append the counter value. So let's run that. Okay, so it looks like we're running into an error. Argument of type float is not iterable. Well, okay, so I'm going through this, and it's saying the error is over here. So it's probably referring to some value of I that's being passed through that it can't search through. So let me go ahead and just add in a print over here so I can see what I it gets stuck on. So it looks like it goes through first name and then stops. So you know what it is? It's probably this NaN over here. NaN stands for not a number, and it's Python, or it's Panda's way of saying null, basically. There's also not a time, but it's really confusing, and I'm not sure why they can't just have a null value. But this, I think these register as floats. Floats basically meaning decimal numbers. So let me go ahead and try something else. Let's go ahead and drop these NaNs. So I'm going to create a new data frame. We'll call it drop NaNs equals drop extra, and then we're going to filter out the NaNs based on the row type column. Dot not NA is how we can do that. And then you'll see we have filtered out our NaNs. You see this NaN over here was index 1. It was index 1, but now it is index 1 is gone. So let's go ahead and do that. So drop NaNs, we've done that, and then let's go ahead and refer to drop NaNs over here. That should fix our value. Cool, and it looks like that did it. So now we have a list called column values, and as you can see, it starts off with 1, then goes to 2, 3. So let's go ahead and make that a new column, and then that should we'll make that a new column in our data set, and that should group all the values together. So we'll go ahead and put in iter calls equals drop NANs, and then let's go ahead and add a new column like this. And you guys might be wondering why I'm using and why I keep creating new data frames. The reason for that is that I've done a lot of data cleaning exercises, and oftentimes I'll make a mistake at some point in time. And if I'm working with a large enough data set, it actually takes a while to run each step. Obviously, this is only like 58,000 rows, so it's not that much, but it takes a while to run each step sometimes. And because of that, I may want to roll back a change to the last variable, which is why I create a new variable every time I'm doing a new step. So we're going to say this equals column values, and then let's go take a look at iter calls. Cool. And then let's click on this, expand this window a little bit. I zoomed in a little bit so it's easier for you all to see. Variables, let's expand that. We can go look at all of our variables, and let's go look at iter calls, that data frame. So I can see it says 1111111, and then it changes when it encounters a first name again, 2. So it looks like our logic is working, and it does the same thing over here, 3. So now what I need to do is I don't need these, now that we've now grouped all of our values together. So like I know, for example, this is all the first data set, and then over here is the 5994th data set. Let's go ahead and get rid of these rows, these column names, because we don't need them anymore. Excuse me. Or we never really needed them. We could have gotten rid of them earlier. So let's say drop extra column name rows, long name, but I have code completion, so that's all right. And then we're going to say it equals iter calls. And then we're going to filter where it says row type. So row type equals row type. Or does not equal, because I don't want these values. So exclamation mark equals. And as you can see, because of code completion, I can have these long variable names, and it's okay. All right, looks like you see how we got rid of the second index, 0, 2. We wanted to get rid of 2, and that's not here anymore. So we did that. Awesome, awesome, awesome. Now what I need to do is I need to separate this over here from these over here. So I'm going to do the same thing again. So I'm going to call it name data frame, because I'm going to separate them like this and then combine them like that. I'm going to join them. So name data frame equals, and we'll call it drop extra name rows, and then we'll refer to the row type column. And let's see. And I want to only get strings that contain first name, because again, we could, in this data set it doesn't change, but this could change like John and stuff. So I'm going to use something called well, I don't know what it's called, but basically in pandas, they have these things, these string methods, where I can type in .str, and it'll access each of these strings individually and allow me to apply logic to each of them. So .str.string, and I'm going to do contains, and I want it to contain first name. I really wish I had the first take of this video, because in the first take of this video, I actually fumbled around a little bit looking through the documentation to find something that works over here. But unfortunately, I forgot to record my screen that time. And as you can see, we've gotten all the first names out. And we can even drop these extra columns over here and do some renaming. Because this should be called first name, this column over here, or this column should be called first name. This should be called iter number, and this should be called, this should be called last name, and this should be called date over here. And then we can drop these over here. So let's go ahead and drop those columns first. So name data frame dot drop, and then what is it? We have to do columns equals, and then I want to drop speed 1, speed 2. I want to drop electricity. How do you spell electricity? I do not need to know. I can just copy and paste. I used to always tell my parents, or basically anyone that would listen, like, what's the point of spelling these? Like, autocorrect will take over the world. Or we called it spell check back then, because it was like, This is before the iPhone, like with Word and everything. But spell check will take over everything. And yeah, as long as you can spell basic stuff, you know. I spell check everything. I never handwrite anything anymore. Okay, so we do this drop, and if you notice when I run this, interesting. Columns equals. I think there's no space over here. And as you can see, I ran this, right? And these values are still here. Well, that's because new dataframe.drop, what that does is it creates a copy of the data frame, and it doesn't actually commit your changes. So in order to commit your changes, there's two ways you can do it. You can go ahead and set new data frame equal to that copy, or for some reason, what I prefer to do is I prefer to use in place. And I really want to make sure you guys know this, because when I was starting off with Pandas, this in place thing was incredibly complicated for me. By doing in place, it'll actually commit the changes to the data frame. So we'll do that, and then let's go ahead and rename our columns while we're at it also. So name dataframe.rename, and then you do the same columns, because it has to know if it is renaming rows or if it's renaming columns, so I have to specify. And then use a dictionary. So we'll rename row type to first name. We'll rename iter number to last name. We'll rename power 1 to date, and iteration can stay as is. And we have to use the same in-place logic here. All right, clean. Now, one last thing you might notice is that I don't want this first name, last name, date in here. It should just say, because we already have the column name over here, right? So it should just say person, human, end of time. So let's go ahead and do a couple more changes. So we'll do name data frame, first name, because that's the name of the column now. So first name equals, and then let's go ahead and refer to this again. .str. So remember, this is referring to that string, and I'm going to use string slicing. So basically, I want to take the last couple of indices of the first name, and so I don't want the 0, because remember, Python starts counting by 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't want the first 10 values, so I think I counted wrong. 5, 6, 7, 8. Oh, maybe I counted correctly. So I don't want the first 11 indices, I believe. So what I'm going to do is I'm going to say start at 12 and then take all the values after that. And then with last name, I want very similar logic. Except last name, as you can see, has just one fewer character. So I'll probably change that to an 11. And then I need to change this over here as well. And then finally, date uh, 4, 5, 6 minus 1, but plus 1 because we want to go from the 6th index. I think that should work. So let's go ahead and recreate name. Oh, name data frame is already being recreated. Okay, good. So when I run this, cool. As you can see, we've gotten rid of all of our unnecessary data. Now all that's left for us to do is to merge these two data frames together. And I know I'm going through this quite quickly, but it actually took me maybe 10 to 15 minutes of just planning out this logic and kind of drawing it out to see, how am I supposed to clean this data? I mean, data cleaning can be a lot of fun, because you can get some really it's kind of like a puzzle with some data sets. So, but obviously it's not what you want to be doing all the time, because at the end of the day, it's probably not, or it's very high value add work, but it's not what, it's not the most interesting stuff in the world. I know I just said it was interesting, but So let me go ahead and create a new data frame where it doesn't have any of this first name information. So, oh, that wasn't it. I wasn't supposed to copy that. I need to copy this. Let's go down here. So we'll call it no name data frame. And then basically I want the exact opposite of this logic over here. So one thing you can do in Pandas is use the inverse operator, which is just this squiggly line over here. And as you can see, it pulls the exact opposite rows that I pulled using this logic over here. So that's a really easy way if you need to split a data frame into two different sections. Just write one condition and then have one inverse the other. So that's what we'll do. Cool, so now we have this, and these are all fine. So now we just have to merge the data. Merge is just another word for join. And the merge function I've heard is generally preferred to be used in pandas than the join function. I don't know why. It's really confusing because SQL, like everyone knows about SQL joins, so I don't know why they had to go, create their own version of it, but such is life. So pd.merge, and then I need to specify the left data frame. So I want the first name and last name to be on the left-hand side of the data, and that's because you should see who is the person you're reading the data on first. So left equals name data frame. Let's say the right data frame equals no name data frame, and how is basically what type of join we're using. So we're going to use an inner join. We could use any join in this case, I think, and then on, basically what columns are we joining on? Because they're both the same, they're called the same thing, we'll just join it on iteration. Otherwise, I would use like left on to specify the left column I'm joining on, and right on to specify the right column I'm joining on. If I run that, I believe that's our clean data right there. You have the name, the date, and then you would probably just drop iteration, and then all the relevant data over there. So that's about it. Yeah, there's nothing else to it. I would have just outputted this as a CSV or put it into a SQL database or something. So this is just a small taste of some of the work we do as data analysts. So if you're at all interested in learning more about how Python works, or if some of this was a little bit confusing to you, be sure to check out my YouTube channel, and I might just pin it up here too. I have a free Python tutorial, 3 to 4 hours, and you will know how to do all of this stuff, and much, much more. There's much more to being a data analyst. This is just one aspect of the many things that we do in our jobs. But thank you guys so much for joining. If you want to support my work, please like, comment, and subscribe on the video. That kind of engagement with the video is really great for the YouTube algorithm. And if you are quite really compelled to support the work I'm doing here in spreading the work of analytics, data science, and data analytics, then feel free to support my Patreon, which will also be linked in the description below. Down there, you can join our Discord channel, support my work, and for new work that I'm doing, so for example, going through the book Hands-on Machine Learning, or I'm about to go through the book Practical Statistics for Data Scientists, any of the notes I create for you will be available in the Patreon. So that's just a great way to support my work, and there will be a couple of benefits in there as well. But thank you guys so much for your attention, and I hope you have a great day.